Hi, it's me again, and I want to show you how you can use the graphing calculator to help you with section 2.5. In particular, you should be able to use a calculator to graph piecewise defined functions as well as the greatest integer function. So I have a few examples that I would like for us to consider here. The first one is a piecewise defined function. F of x is equal to 1 minus 2x for x less than 3. X plus 1 for x greater than or equal to 3. So the way this will work is you're going to enter each piece of the function into a separate equation. So that is this 1 minus 2x we're going to enter into y1, and x plus 1 we're going to enter into y2. Now what we're going to do is enter this function in parentheses, and then we're going to do a division symbol, and then in parentheses the restriction on x. Now what this will do whenever we enter this inequality statement x is less than 3, this is something called Boolean algebra. And a value of either 0 or 1 is assigned to it. If x takes on a value which is indeed less than 3, then it is true and it assigns a 1 to it. And anything divided by 1 is itself, so it hasn't changed the value of that function. If x is not less than 3, say 5 or 6, then that is false and it assigns a value of 0 to it. And we know that something divided by 0 is undefined. And so what is happening is your calculator is basically doing this. It's going to show the graph for portions on this particular restriction that make it true, but it will not show it on values that do not make it true. It's kind of like when we graphed by hand, we erased the part where our domain was not defined. The calculator does that for us. Now, how do you get the less than symbol? You're going to use the test menu. You have to do second math to get the test symbols. Okay, so let's take a look at what this would look like on the calculator. So I've already done this for you. So if you press Y1, and then here I have in parentheses 1 minus 2x, close parentheses, divided by, in parentheses, x is less than 3. So again, I do the test menu and choose the appropriate inequality symbol. Then I go to Y2 and enter the other function, x plus 1, divided by x is greater than or equal to 3. Now, your calculator will not tell you where you need an open and closed circle. You have to know that on your own. And also, if you look at the table, at 3, well, the first function is not defined at 3, so you're going to see it undefined there. Y2 is going to be defined there. 3 plus 1 is 4. So we know that 3 4 is included. But what you don't know is the endpoint where you need to put an open circle. So you would have to find that by hand. So if we put in a 3 in the first equation, 1 minus 2 times 3, or 1 minus 6, is negative 5. So at 3, negative 5, you would have an open circle there. Now let's look at another example, one that is a little bit more involved. F of x is equal to 5 for values less than or equal to negative 1. It's equal to x minus 1 for values between negative 1 and 2. And it's equal to x minus 3 squared for values larger than 2. So 3 pieces to this, so we're going to have to use y1, y2, and y3. The trick to this one is this middle restriction. X lies between negative 1 and 2. What that really means is that x is greater than negative 1 and x is less than or equal to 2. So we actually need to type it in that way. Your calculator doesn't understand these statements unless the variable comes first, so you're going to have to translate that into this double or compound inequality. So to do that, let me go to my, here it is. Now the 5 I didn't put in parentheses. If it's a single number, you don't have to do that. But so we did 5 divided by the restriction where x is less than or equal to -1. The middle piece is x minus 1 in parentheses divided by x is greater than -1. Now to get the and, you're going to go to the test menu, so do second math, and then arrow to the logic menu. And the number 1 is and. Then you go back to type in x is less than or equal to 2. Now the third piece is x minus 3 quantity squared divided by the restriction x is greater than 2. So hopefully this makes sense. We have a horizontal line, a linear function with a positive slope, and then a parabola. Now how are those endpoints going to be designated? Okay, at x less than or equal to -1, we can include -1 there. So we know at -1, 5, we have a closed circle. What about at this piece? Right, x is not equal to -1, so we would have an open circle, but what is the point? -1 minus 1 is -2, so at -1, -2, we're going to have an open circle. At this endpoint, when we plug in 2, 2 minus 1 is 1. Now something interesting happens. For the next piece, when we plug in 2, even though it's really not included, 2 minus 3 squared is what? -1 squared, which is 1. So these two graphs happen to coincide at that endpoint. So even though it's open for the third function, it's closed for the second. So a closed takes over something that is opened. Now the last thing is a greatest integer function. To graph the greatest integer function on the calculator, you press your y equals key. Oops. Sorry about this. Oh, well, guess I'm not going to press my y equals key. You would press your y equals key. There it goes. Delayed. And then you're going to press the math key, go to the number, and option 5 is the integer. And you're going to have to use the dot mode to graph, and we'll look at that. So here's this. I did math, number, and then option 5 is the greatest integer function. So it comes up as int, and then you're going to type in the x and close parentheses. Now the default is that the graph is in connected mode, but you want to turn it to dot mode. Otherwise you don't get that constant functions or those step pieces. You get something that looks like it's all connected. So go to mode and arrow down to connected and highlight dot and press enter. And then when you graph, you should see this step function. Now you're going to have to remember which side is open and which side is closed. So it's always closed on the left and open on the right. Closed on the left and open on the right. Okay? And you could do the transformations just by typing those functions into the calculator. So if you have any questions on this, don't hesitate to contact me. Thanks.